Hey everybody, Matt Morgan here. In this lesson we're going to talk about drawing Lewis structures from OpenStax section 7.3. In this lesson we're going to go over what the Lewis model of drawing molecules entails. We're going to go over the steps of how to draw Lewis structures. Then we will work some examples with water, the ammonium ion, and finally carbon dioxide. So in section 9-1, we saw the Lewis structure for an individual atom. This was the atom symbol surrounded by dots that represented the number of valence electrons for that atom. The Lewis structure for calcium would be its symbol Ca. Since calcium is in group 2, it has 2 valence electrons. We would see calcium with 2 dots on it. So why do we draw Lewis structures? Lewis structures are simple models that give us an idea of how atoms are arranged in a molecule. The Lewis structure for atoms, not so informative, but for molecules we can see the types of bonding, whether it's single bonds or double bonds, and we can also see the structure. What we do by drawing Lewis structures, we take all the valence electrons, we make octets for all the atoms that need them, and then that shows us how the atoms are arranged. And the purpose of bonding, as we've seen from previous lessons, is for atoms to get their full electron shells, the nearest noble gas. They want that noble gas configuration, and we will see this in Lewis structures. So in addition to seeing the kinds of bonds, we can use the Lewis structure to help determine a molecule's shape and polarity. Now the Lewis structure by itself does not give us information on the shape, but we can take the Lewis structure and apply some other information to get the shape and whether or not the molecule is polar. So how do we draw Lewis structures? Boromir's kind of right. You can't simply draw a Lewis structure, kind of like simply walking into Mordor. There are some steps, and we'll go over these. Wiley section 9-4 shows some rules, shows some steps. It's kind of a jumble. So what I'm showing here is a more focused method. It's a little bit different than what Wiley shows, but what you should do is use the method you like best, but make sure you know how to draw Lewis structures. That is a skill you will have to display on the assessment. So step 1, we're going to count all the valence electrons for every atom. Valence electrons are those available for bonding, and it's the same as the group number for an atom. If it's a polyatomic ion and it's positively charged, we'll subtract 1 electron for every positive charge. If it's a negatively charged polyatomic ion, we will add 1 electron for every negative charge. After we have the number of valence electrons, we will draw the structure. We will put 1 atom in the middle, we'll surround it by other atoms, and we'll draw bonds in between those atoms. Every bond represents 2 electrons. We use the remaining electrons after the bonds to make octets around all the atoms. We'll put octets around the outer atoms first, then the remaining electrons on the center atom. If we run out of electrons before every atom has an octet, then we make a double or a triple bond. We'll see an example for that later. If we have any extra electrons, we'll place them on the center atom. There may be times when an atom has more than 8 electrons around it. If so, make sure that atom supports expanded octets. Draw resonance structures if necessary. Calculate formal charge if necessary. We'll go over those topics in a later lesson. Big picture is we need to find spots for all the valence electrons and give an octet to every atom that needs one. This concept is so important, I'm going to say it again. The big picture is to find spots for all valence electrons and give an octet to every atom that needs one. Let's work some examples. So what you might want to do, go back to the video, pause on the steps, make notes for the steps in writing a Lewis structure, then follow along as we work these examples. We'll start with water, one of my favorite molecules. First, we count the valence electrons. Oxygen is in group 6A. It has 6 valence electrons. Hydrogen is in group 1A. Each hydrogen has 1. There are 2 hydrogen electrons. So our total number of valence electrons is 6 for the oxygen, plus 2 times 1 for each hydrogen, giving us a total of 8 valence electrons. So we are going to place 8 valence electrons, give every atom that needs it an octet. You've got to get the correct number of valence electrons in order to get the correct structure. Now we'll draw the structure and we'll count 2 electrons for each bond. 8 valence electrons. We know oxygen is in the middle because hydrogen only bonds once. If hydrogen goes in the middle, it will bond twice, and that goes against our HONC 1, 2, 3, 4. So oxygen in the middle, hydrogens on the outside. There's our bonds. Each bond represents 2 electrons. So we have taken up 4 of our valence electrons with bonding. That gives us 4 more electrons we have to place. They're going to go on the oxygen. Hydrogen doesn't need any more. Hydrogen doesn't need an octet. When it has 2 electrons, it meets its nearest noble gas configuration requirement. So we put the remaining 4 electrons on the oxygen. We have placed our valence electrons. We've placed 8 electrons. Oxygen has an octet. Hydrogen is happy. Every atom has what it needs, and our Lewis structure is complete. That is the Lewis structure for water. You may have seen water written as a bent molecule. This is still a correct Lewis structure because the Lewis structure by itself does not tell us about molecular shape. So this is a good Lewis structure. Let's work another example. The ammonium ion. It's a polyatomic ion, and we can draw its Lewis structure as well, just like a molecule. So let's first find our valence electrons. Nitrogen is in group 5A. It has 5 valence electrons. Each hydrogen has 1. But we will subtract 1 electron because this polyatomic ion has a +1 charge. Electrons are negative, so if we have a +1 charge, it means we're missing an electron. So our total number of valence electrons, 5 plus 4 times 1 minus 1, giving us 8 electrons. We put our nitrogen in the middle, surround it by the hydrogens, create our bonds. Well, with 4 bonds, we've used 8 electrons. There are no more electrons to place anywhere else. There are no lone pairs on this ion. Because this is an ion, a polyatomic ion, we're going to put brackets around it and put the charge on the outside. There's no specific charge on any one of these atoms. That +1 charge is smeared out over the entire polyatomic ion. Notice that this is an exception to HONC 1, 2, 3, 4. Nitrogen is bonding 4 times, but it's a polyatomic ion, so I guess that's why we have our exception. Let's work one more example. Carbon dioxide. Carbon is in group 4A. It has 4 valence electrons. There are 2 oxygens, so we have a total of 16 valence electrons. We place our carbon in the middle, surround it by oxygens. We've used 4 electrons in bonding. We have 12 left that we have to place. 6 on one oxygen, 6 on another. We've used all our valence electrons for the bonding. 12 for the lone pairs. Are we finished? No, we're not. If you notice, carbon does not have an octet. Oxygens have the octet, but carbon needs one. So we've run out of electrons. We can't just place more electrons. We only have 16 to work with. So what do? When we run out of electrons, and not every atom has an octet, we form multiple bonds. So we're going to take a lone pair from each oxygen and turn that single bond into a double bond. Do that for the other side. Lone pair goes away, double bond gets formed. Now we've used our 16 valence electrons. If you count up, there's 2, 4, 6, 8, 10, 12, 14, 16. Every atom has an octet. And we're done. In this lesson, we talked about how to draw Lewis structures and worked some examples. Practice makes perfect, so be sure to do the homework problems, and of course contact me if you have any questions. Here is my contact information. There's my email. We have online office hours Tuesday and Thursday mornings, 9 to 10 a.m. And you can make an appointment if those times don't work for you.